Shut up. You know, when I load my SD card, I've been getting random pictures of people. Alright, so C, f of x, if C is greater than 1, I get a vertical stretch. If C, okay, is between 0 and 1. So think about numbers that are between 0 and 1, like fractions, right? Fractions between 0 and 1, like a half, okay? Well, if I multiply my y values, okay, by a number between 0 and 1, let's say that we use a half. So let's say instead of this 2, we make it 1 half. Okay? What's that going to do to that y value of 1? What's it going to take it to? 1 half. Okay? So I've got -5 comma 0.5. We'll have, again, -2, 0 stays where it's at. We'll have 0, -1. We'll have 1, 2. We'll have 3, 1.5, and 8, 1.5. And now when we do that, connect those points. Huh? Ah, okay. Thank you. Should be something like that, right? Okay, so that last point. 1.5, not 1.53. But now does it look like that thing got squeezed down? Okay. So when we squeeze something down like that vertically, okay, we call that a vertical compression. Vertical compression. Okay, so alright. So that's when we multiply by some constant out in front. Okay. Now, kind of think about the numbers we've used here. We've basically used anything from, obviously if I multiply by 0, that's why we don't include 0. If I multiply by 0, the function just goes away, right? It gives me just the horizontal, it gives me the x-axis basically. But we've used all our numbers from anything greater than 0 all the way up to infinity, right? This gets me 0 to 1, and that gets me 1 to infinity. Okay. Obviously if I let it be 1, it's just f of x, so it's kind of I guess it's trivial. It's not a big difference in the graph. There's actually no difference in the graph. But what about negative numbers then? Okay. What happens when C is -5? Okay. Well, the 5 still stretches it vertically. Does that make sense? But the negative now takes your y values and makes them turn into their opposites, right? So when we talk about this, the idea is still maintained even if we use negative values, but when we use negative values, there's an additional transformation being applied. Okay, so you really get, when I say like this number out front here is -2 or -3, there's two transformations there. There's a stretch of 3 or a stretch of 2 or whatever, but then there's a reflection across the x-axis, and we'll get to that here in a moment. Something that we talk about briefly at this stage with transformations is what happens to, we've done a vertical stretch, we've done a vertical compression, okay? And if we compare what we've done up here, we did a vertical and then we went horizontal, right? So we should be able to go vertical and then have the same kind of relationship horizontal, okay? So we should be able to have horizontal stretches and horizontal compressions. And I'm going to write this down what it looks like, okay? But if you think about how the relationships existed here, a vertical is adding to the y's, and a horizontal was adding or subtracting to the x's, right? So here, a vertical stretch was multiplying the y's. What are we going to multiply now? Multiply the x's. So if I write something like f of c times x, okay? Now if c is bigger than or equal to 1, okay, we're going to call that a horizontal stretch or a horizontal compression. I want to kind of look at a GeoGebra here to see which one that might be. Okay, if we're gonna recognize what it, whether it's a compression or a stretch. So, got it here somewhere. Alright, so I just want to we'll just deal with something easy first. X squared, okay, so there's our parent function, okay? And you see that, put parentheses, or the way I've written it is that we're going to take some value, some constant, call it A here, call it C over here, doesn't really matter. We're going to multiply our X by that. So we might double or triple or quadruple our X value, okay? And then we're going to square it, okay? And then see what that output value provides us. So, when I have an X value, say like 1, and this number here, let's say we take that X value 1 and now multiply it by 2. So I'm going to have a 1 there, multiplied by 2 gives me 2, right? Now I square that 2 and I get 4, correct? So an X value of 1, okay, just gave back a Y value of 4, which normally in the X squared function, an X value of 1 gave me back 1, right? Okay? So we see there's some amplification here in that Y value. And I'm going to put in the parent function X squared so we can see kind of the comparison here. So that's the parent function. Okay? But what's happening here is really that point right there. Because it was 2, 4, right? That point right there, the X value just got cut in half. Does that kind of make sense? Okay? And the cutting in half comes from the fact that we were using a 2 there. Okay? If I change that to a 3, see if I get that point. It's not going to be exact, but you see you can see in the comparison that what that 3 does. Okay? But what's happening here, okay, is not necessarily what you might think visually. Okay? We start with X squared, okay, and now when I start changing that coefficient in front of X, people think, well, that looks just like a vertical stretch, right? Okay? Looks like I'm pulling it up. But really what you're doing is you're squeezing it down. You're squeezing it horizontally. Okay? And it's really hard with a lot of our power functions, our root functions, our reciprocal functions. It's really, really hard to see that it's being squeezed in comparison, horizontally, in comparison to being stretched vertically. Okay? So here's some, we'll write it down, okay, because they might, just kind of in a generic question in WebAssign with some generic f of x, they might do something like this and ask you, what's going to happen to it? It's going to be a horizontal squeeze or a horizontal compression. Okay, horizontal compression. Okay, but what happens, what do you think is going to happen if C is between 0 and 1? If greater than 1 was a compression, what's the other option? It could be a stretch. Okay, so when I make this go between 0 and 1 and make it increments which go by 1/10. When I change that now, okay, now you see, starting with the parent function, okay, when there's a fraction out front or a number between 0 and 1 out front, you can see now that that parent function is getting pulled apart, right? Okay, so it's a horizontal stretch. But what it looks like also is that maybe it looks more like a vertical compression, right? If I put my hands on the top of that square and push down, it's going to kind of bow out, right? So it's really hard to make a distinction visually of the graph. Okay, say I give you this function here and I give you the parent function on the same thing. Okay, so I give you those two graphs together. Okay, somebody might, and I don't give you any of the algebra on the left hand side, but some of you might say, well, that's a vertical compression. Some of you might say it's a horizontal stretch. Okay, and visually they look the same, don't they? So what happens is a lot of times we don't necessarily talk about horizontal stretches and compressions in great detail early on in the course. It's not until trigonometry that we start talking about these things in a little bit more detail. And I asked the last class, the people that are in physics, they haven't seen this stuff yet. Oops. There we go. But that is a trigonometric function. That's sine of x. Okay, it's the sine key on your calculator that we've dealt with in algebra 1, geometry, algebra 2. But if you're in physics, maybe you've talked about sound waves, light waves, that kind of stuff, radio waves. The way that your computers communicate with the Wi-Fi is through waves like that. Okay, those are a little bit easier to see that we have horizontal stretches and compressions. Okay, so I'm just going to put the parent function here. So I'll write sine of x, and then if I put an a in here. Okay. Now what I want you to think about is that a sine function or cosine function is like a spring. Does that kind of make sense? Okay. And if I put my hands on the end of it, One, 2, 5, 6, 0, 0, 0, 0, 0, 0, 0.
Can I answer it for you?
Answer.
No.
Oh, I had a prank call already.
Alright, so if this is a spring, so if you put your hand over here and put your hand over here, okay? And now grab a hold of that spring and you're either going to pull apart or you're going to squeeze in. And you can see what happens here, okay? As A gets bigger, what are you doing there with your hands? Are you pulling it apart or are you squeezing it down? Squeezing it down. So you're compressing your hands, right? So you compress the function, okay? So that is a lot easier, that transformation is a lot easier to see for our trigonometric functions, okay? Now if I'm between 0 and 1 then, now you see that you're doing what? Stretching it. Okay, that's a horizontal stretch then. And those are a lot easier to see with those sine, cosine functions. Okay, even the tangent, cotangent, secant, cosecant functions are the same. But these types of functions are called periodic. Okay, periodic in the fact that they repeat themselves over some interval of x, over and over and over again in the same manner forever. Okay, so that's what a periodic function. And these horizontal compressions and horizontal stretches are best seen on a test or quiz. I'm not going to ask you right now about those horizontal compressions and horizontal stretches because I think it's maybe unfair visually to think about that. If we look at taking, we'll talk about two more real quick. What if I take f of x and just multiply it by a negative? Good. X-axis, reflection. Okay, so we're going to reflect across the x-axis. So, if I reflect across the x-axis, what values are impacted? We've talked about these mean y values, right? You're putting a negative in front now. So what values, what coordinates are getting impacted? The y. Okay? So now when I multiply every y value here by a negative, it's going to be -5, -1. So give me -2, 0. Give me 0, 2. Be 1, -4. 3, -3. And 8, -3. If I start connecting those, the hope is that you can see visually that all you've done is you've taken the curve that you had and everything that was above it, everything that was above the x-axis now became below it, right? And everything that started off below it has now gone above it. Okay, and it's just altering those y values by a negative. Okay? So here's a question, and what happens if instead of multiplying the entire function by a negative, or the y values by a negative, we should be able to do this, right? So that's going to be a y-axis reflection. Okay? So y-axis reflection, okay, what values get affected? The x's, okay? So now it's going to be 5, -1. sorry, 5, 1, 2, 0, 0, negative 2, negative 1, 4, negative 3, 3, negative 8, 3. And now if I connect those, try not to mess this up. But right? I'm missing something there. 2, 0. Say again?
You got the 0, negative 2 at the bottom.
So we're going there, right? And then up. And then up. Okay, there you go. So now, if you look at the black one, reflected over the y-axis, does it land on the red one? Yeah. Okay. If we look at this, it's horizontal shift. I'm going to go y-axis reflection. Okay. I want to talk about it's easier to see, I think, a y-axis reflection in regards to a cubic first. Okay? And basically all this does is it toggles between 1 and negative 1 up here. So you see that with a positive 1, just x cubed, we have this curve. But when it goes to negative 1, we multiply the x by a negative first, and then cube it, and is that a y-axis reflection? Okay? If maybe even the square root might be even better to look at. Square root of a times x. So there's your square root function. If I multiply the x by a negative, so you see the negative underneath the root, that's a y-axis reflection, right? Okay. What if I do this? What if we talk about this function? A times x to the second. And I toggle back and forth. It's changing the function, right? But why am I not seeing a different graph? Right, because it's symmetric with the y-axis, right? So when it's symmetric with the y-axis and I flip it, it just gets you what you started with, right? Okay. So there is a reflection going on there, but it's not obvious. If I move this thing away from the origin, so maybe I put like plus 3 there. Okay. So plus 3 moves it to the left, right? But now I start adjusting that negative. Now you see that we're reflecting across the y-axis, right? Okay, it bounces back and forth. There is and we'll get to this hopefully on Monday, but there's something I want you guys to look at, because what's going to happen, we viewed these today individually, right? But in our functions, it's going to be very rare that we just talk about an individual transformation. We're going to start combining them, all right? And when you combine them, and you want to graph something with that combination of transformations, they are, for the most part, independent. And what I mean by that is, if I want to shift it left first and then down, I can do that. Or if I wanted to shift down and then left, I can do that. Does that kind of make sense? Okay? They're independent for the most part, except for vertical translations and reflections across a particular axis. And actually, like I said, a horizontal translation and a y-axis reflection, those are kind of dependent on one another. So if I'm moving left and right and then reflecting across the y-axis, I want to make sure the order that I do those. Same thing if I'm moving up and down and then when we reflect across the x-axis, I have to be cautious of the order that I do those reflections. Okay. So this is going to help, I think. Okay, maybe going through those things first, but doing that vertical translation last, and maybe even at times doing a horizontal translation. I would keep the translations are the easier of the transformations to do, so I would keep those for last, and do the harder parts, the stretching, the reflecting, and then do the vertical and horizontal translations last, because of how a reflection can impact what we want our graph to look like. And I'll explain that in detail with an image on Monday, and hopefully you can see the connection, and it will remind you that you've got to be cautious when you have both those things happen in the same function. Just finish others. You don't have to finish it, it's not due until Tuesday, but there's still that web assign open for 2.5 and 2.6.
Yeah.